Hello everyone, in this video we are going to see the solution of question number 7 from exercise set 8.3 which belongs to class 9 CBSE chapter 8. Let's look into the question. The figure shows stage 0 to 3 of Sierpiński square carpet. Stage 0 of this fractal is a square sheet of paper. So there is one square sheet of paper which is at stage 0. To construct a stage 1, so what we are going to do, we will divide this square sheet of paper with a trisection. So every side is going to divided into three parts. Trisection means three equal parts. Like that we are going to divide each and every side. That is what our stage what 1. Okay, so this intersection is happening now. So over here we are going to remove this square, so it's nothing but like this. So totally how many squares came after the intersection? This side 3, 4, 5, 6, 7, 8 and 9, but one square has been removed, so totally 8 red square and one square has been removed. That is what they have mentioned over here. So coming back to the question, to construct the stage 1, what we have did now, to construct the stage 1, each side of the square is trisected and the points of intersection of opposite sides are joined to obtain 9 smaller squares. Yes, right, 9 smaller square we made, and the center square is then removed and the 8 smaller squares are retained, leaving a square hole in the center. So center square we removed and remaining 8 squares were there, and here there is a hole at the center. The same process is repeated on 8 smaller square shaded squares to obtain stage 2 and so on. So what they are saying, so what process we did now, the same process is going to happen for each of this small square also. See, now if I now I'm going to trisect each side of the smaller square, so I'll be getting 9 smaller squares inside that, and the center square will remove. That is what this one. Like that, each of the 8 squares are going to follow it. Okay, and then in the next stage over here, each square is going to be divided into 9 squares. Like that, these stages are going to process. And now by seeing this figure we are going to find the answer for the questions. The first question is how many red squares are there in stage 0 to 3, and can you predict the number of red square in stage 4 and 5? So first we'll solve these two problems. First and here the first question is how many red squares are there in stage 0 to 3? Okay, by seeing we'll get the information, then we'll make a tabular column. So by seeing stage 0, how many red squares are there? One red square. By seeing stage 1, how many red squares are there? So this one red square is going to be converted into totally 9 square. But among 9, one actually we have removed. So remaining 8 red squares are there, right? Yes, so you can make it as 8. And in stage 2, each of this red square is divided into 8 more red square. Okay, then totally we have 8 small square, and each of the 8 small square is going to be divided into 8 more squares. So 8 into 8, 64. And now at stage 3, what is going to happen? We have totally 64 red square, and each of the 64 red square is going to be divided into 8 more red square. So it is 64 into 8. So how can we write this problem? Write stage and the number of red square. So at stage 0, how many red square are there? 1. At stage 1, there are totally 8 red square. At stage 2, 64 red square. At stage 3, 512 red square. So we want actually till stage 3 only. So this is enough. But here the question is how many red square are there from this to this now? You need to add everything. So totally the number of red squares are how much? 1 plus 8 plus 64 plus 512. So total red squares from stage 0 to 3 is going to be 585. Okay, so this is the answer for our first subdivision, and we'll see the second sub question. Can you predict the number of red square in stage 4 and 5? So can we continue here itself, 4 and 5. So stage 4, how many red squares are there? So how you will find? In stage 3 we have 512 red square. Now in stage 4, each of this 512 red square are going to be divided into 8 more red square. So 512 into 8, which is going to be 4096. What about stage 5? So each of 4096 red square are going to be divided into 8 more red square. So it's going to be 32,768. So this is the answer for our second question, and this is the answer for our first question. Now we'll see the third question. Here the third question is, can you find a rule for the number of red square at the nth stage, and write the explicit formula as well as recursive formula for the number of red square at any stage. So as we already know, right, what is the stage and how many number of squares, red squares. So we have already calculated where in our first two questions. So here we are going to do the same thing. First we will write and we'll find the formula for it. Okay. So now at stage 0, how many red square? 1 red square. And in stage 1, how many red squares are there? So this 1 red square is going to be divided into 8 red square. So I am writing this as 8. And in stage 2, how many red squares are there? So stage 1, 8 red square are going to be, each red square is going to be divided into 8 more red squares. So I can write this as 8 into 8, or even we can write it as 8 square. And what about the stage 3? So each of this second stage red squares, the red squares came in stage 2, all are going to be divided into 8 more red squares, right? So I can write this as 8 into 8 into 8. So these are the red squares in stage 2. Now each of these squares are going to be divided again into 8 more red squares. So it's nothing but 8 power 3. So this is what we have the data. So now we need to make the explicit as well as the recursive formula for this data. So what is explicit formula? So for the nth stage, what will be the number of red square? So what will be the number of red square? I can write it as 8 to the power n, right? So this is what our explicit formula. So how can we write that? Tn equal to 8 to the power n. So this is the explicit formula for the third question. Okay, now still we need to write recursive formula also. So what is the meaning of recursive formula? We are going to define a particular term with respect to the previous term value. So for example, so for a recursive formula, the first stage we only need to define. So Tn value equal to, what is the value for us? 1. When it is going to be 1? When n is equal to 0. Same way, I can write Tn value with respect to the previous value. How can we write this? Can we write 8 into T n minus 1? See over here, if you see, this 8 is from the previous stage, and this 8 currently we are going to multiply. So each of the previous stage red square are divided into 8 more red square. So can we define like 8 into T n minus 2? This is what our recursive formula for the question 3. Now we'll move on to question 4. Suppose the area of the square in stage 0 is 1 square unit. What is the area of the red region in stage 1, 2, 3? First we will define this. So I'll add one more row. So over here, what actually we want? Area of the red square, right? So area of red square. So what is given over here in the question? At the stage 0, the area is 1 square unit. Then what about the area during the stage 1? So first we need to understand the concept over here. Coming to the diagram, just come and see the diagram. So stage 0 is having 1 square unit. What about the stage 1? So this 1 square unit is divided into how many parts? Totally 9 parts. Okay, so this is what the area of each of the square in this stage 1. But over here we have totally 8 square only. Including this we have 9 square, but since we have removed it, we have totally 8 red square. So I can write this as 8 into 1 by 9. Listen carefully. So the stage 0 is having 1 square unit. Now in stage 1 I divided this 1 square unit into 9 parts. Among 9 parts, how many are red square? It is 8. So I am writing 8 into 1 by 9 as the area of red square at stage 1. So I can write the area of the red square at stage 1 as 8 by 9. And now in stage 2, these 8 by 9 are going to have one more 8 by 9, right? Times of red square. So we can write over here at stage 2, the area of the red square is 8 by 9 the whole square. And over here 8 by 9 the whole cube. So for this we can define the nth term value, right? That is what our next question. Now still we have the next question as, what will be the area of the red region in stage 4 and 5? So in stage 4, what about the area? So for area I can keep it as an. Okay, so what about the stage 4? So I can write A4 equal to 8 by 9 the whole power 4. And for stage 5 we are going to find the area of the red square. So I can write 8 5 equal to 8 by 9 to the power 5. So now coming back to the next question. Find the explicit as well as recursive formula. So what is the explicit formula for this? So it's just a nth term, that's it, right? So explicit is equal to, so what we have taken the variable an. So an is equal to 8 by 9 to the power n. So this is what our explicit formula. Then what about the recursive formula? So recursive formula, in the sense we need to define the current term with respect to the previous term value. So how can we represent the current term with the previous term value? So an, first we need to define the first value, right? What is that? An is equal to 1, right? For the first stage 0, we have an equal to 1, where n is equal to 0. And from first stage onwards, we need to follow this formula. An equal to, with respect to the previous term, I can write it as 8 by 9 into an minus 1, right? This is how we can define the area with respect to the previous area value. So it's nothing but the recursive formula, right? Yes. So still our question is not completed. What happens to this area as n? The number of stages goes on increasing. So here, if our stages keep on increasing, it is keep on increasing, what is going to happen to your area? So the area is going to keep on decreasing, because each area of the red square is going to be 8 by 9 part of the previous square. So obviously our area is going to be keep on decreasing. At one stage it reaches to 0. Here ends the solution for this problem. Hope you understood. Thank you.